Hello, welcome to Understanding Macroeconomics Lesson 3. This one is still in the unit on the metrics of measuring the economy. And we are now in item number 2, the inflation rate. So let's go ahead and get started. The inflation rate is simply a measure of the general rise in all prices. It's obvious that some prices rise faster than others. Some prices actually fall and some don't move very much. So the inflation rate is just some kind of average of all of those prices all moving in different ways. So there are three common ways that we measure the inflation rate. The most obvious one, and the one that's in the media most of the time, is the Consumer Price Index, and we will spend most of this lesson working from that one, but there are others. There's a thing called the Producer Price Index. Years back it was called the Wholesale Price Index. It's calculated the very same way as the Consumer Price Index. You would use it the same way, but the basket of goods that they're tracking are really wholesale things. So where up here in the Consumer Price Index, it's things that you and I might buy when we go to the store. The Producer Price Index are things that firms might buy. Then there's a third one that's pretty common but it's very different, and that's the GDP deflator. These first two, the Consumer Price Index and the Producer Price Index, are tracked by the Bureau of Labor Statistics. They report a number for every month, so these are monthlies. The GDP deflator is calculated from the Bureau of Economic Analysis. It's connected to GDP, obviously, and so it only comes out 4 times a year, every quarter. Okay, so this is the data, and if you go to our Blackboard page, you will see this in course documents in an Excel file where it'll be much easier to work. But I just thought I would show you that the data that I've compiled. You have here the Consumer Price Index from 2020. The 2021 number obviously is not here yet, and it goes all the way back to 1795. Now, truth be told, we didn't really start calculating as a formal exercise. We didn't really start calculating the Consumer Price Index until about 1933. So starting here in 1933, the numbers have a little more precision, and all these numbers that are before that have sort of been back calculated from the limited data that we had. Anyway, it's a pretty impressive series from 1795 to 2020. Now, what kinds of math questions can come from all this data? The most obvious one is to take an old price, a historical price, and adjust it to the present. People do this all the time. Another one is to calculate the inflation rate between 2 consecutive years. So this is basically just a rate of change equation, and I will post this in a couple of slides. Then this other one is calculating the average inflation rate across many years. You can't do this by just calculating the inflation rate for 2 consecutive years and then the next 2 and the next 2 and so forth, and getting some kind of arithmetic mean of all of those. That will get you close to the right answer, but it won't be correct because of the compounding that's going on in the actual numbers. So to get the real number, the accurate number, the precise number about the average inflation rate across many, many years, you have to use a future value, present value equation, and we'll go over that in a couple of slides. So another thing you can do is you can predict a future price based on some assumption about what inflation will be out into the future. And finally, this is the hardest one, to calculate how many years before prices double or triple or some such thing as that. Okay, so let's start with the easy ones first. So this is the formula that you need to take some price from the past. Let's call it year X. So any price in any year in the past, and you want to adjust it to some other year, probably the present. We'd call that year Y. So what you do is you take this old price, you multiply by the Consumer Price Index in the year that you're trying to go to, that's year Y, and you divide by the Consumer Price Index in the year that your data is in originally, and that will give you the adjusted price. Okay, one more time. You take a price in any year, let's call it year X. you multiply by the consumer price index in some other year where you're trying to go. So typically this will be some year in the past, and typically this will be the CPI for the year that we're in. Then you always divide by the CPI in whatever year this is, right? Multiply by the CPI in the year you're trying to get to, you divide by the CPI in the year that your data is in. And that will get you a result that is the original price adjusted for inflation that has occurred between the original year and the new year. Alright, so this is the inflation adjusted price. So down here on the bottom of this slide, I've worked one out for you. I got my first car in 1972. You weren't born. Maybe your parents weren't even born yet. But I mean, this is not driving my mother's car. This was my car. And gas in that year, 1972, was 34 cents a gallon. Sounds really cheap, but you got to remember that we've had a lot of inflation since then. 34 cents back in 1972 was quite a bit of money. So to figure out what that actually is in today's money, what you have to do is multiply this number by the consumer price index in 2020, and I got it off that page. You can check behind me. So the current CPI is 259.1, and then I have to divide it by the consumer price index in this year right here, which I also looked up. So you do this little math here, and you get that 34 cents in 1972 is the equivalent to $2.11 today. And the amazing thing is that is about the price of gas. There is one complicating thing. This was regular gas in 1972, and of course we buy regular gas, at least I do, buy regular gas today, but the gas is very, very different. This gas had lead in it. This gas that we buy nowadays does not. The refining process back in 1972 really dirtied the air, and the refining process now probably still dirties the air, but not nearly as badly as it did before. So there are a lot of differences between gas in 72 and gas in 2020, but still this is the best we can do. You can take the dollar price back then and adjust it for inflation. Alright, so the next kind of equation that you're going to need is a simple rate of change equation. So if you notice from this thing, if you wanted to calculate the inflation rate from one year to the next, you just take the CPI in some year, you subtract the CPI in the previous year. See, this is year X minus 1. Subtract the CPI from the previous year and divide by the CPI in the previous year, multiply by 100, and that'll give you the percentage change in the price, or in economics terms, the inflation rate. So I did it right here. I took the CPI in 2020 and I subtracted the CPI in 2019. Then I divided that difference by the CPI in 2019, multiplied by 100 to get it in percent, and then the inflation rate based on the CPI from 2019 to 2020 was 1.33%. You should maybe stop this video and work that out for yourself to make sure you can do it. Now, the last formula is this one. The future value equals present value times 1 plus the growth rate raised to the number of years out. This little simple compounding, annually compounding formula shows up in almost every business class. So if you don't have this formula memorized already, you should memorize it now. Now I'll show you a couple of ways that you can use it. First, let's clean the screen a little bit. Now the first problem is, okay, assuming a 3% inflation rate, what will be the CPI in 10 years? Okay, so you would just put the current CPI here and then let it grow at a 3% rate and raise it out to the 10th power. So it would look like this. This is the current CPI times 1 plus 0.03 raised to the 10th power. Work this out in your calculator. You get this number, 1.03 raised to the 10th power is that. Do this simple multiplication. So we predict that at 3% inflation, the CPI in 10 years will be 348.2. It's just a prediction based on this assumption right here. All right, now here's another problem, a little bit harder. What was the average inflation rate from 1960 to 2020? All right, so we do it the same way. This is the the old CPI from 1960. This is the new one here in 2020, right? It's a little bit cumbersome the way the formula is written, but the present value and future value, the one on the left, this is always the one that's farther out on the timeline, and then this is back in history. So here's our old number, here's our new number. We're trying to calculate the growth rate, so it's 1 plus the growth rate. This is the thing we don't know, but we know it's 70 years out because it's exactly 70 years from 1960 to 2020. Alright, so don't let that intimidate you. The first thing to do is to divide both sides by this. That's easy enough. So we divide both sides, right? And now we have 1 plus the growth rate raised to the 70th power over there by itself. So I did this little division, and I have this simple expression. Now if this was 8.753 equals 1 plus the growth rate squared, then you would know just to take the square root of both sides. But since it has a 70 here, which is kind of unusual, some of you maybe are nervous about what to do. What you need to do is take the 70th root of both sides. 70th root of both sides. You're going to probably have to Google your calculator to figure out how to do it. But if you have a $10 calculator, it can find any root. So take the 70th root of both sides, which I did here. So that's disappeared because the 70th root of something raised to the 70th power cancels out. I have this little number on the left-hand side. Now I'm going to subtract 1 from both sides, and I get the growth rate from 1960 to 2020 of prices is 0.0315 or 3.15%. That would be the inflation rate. The growth rate and the inflation rate in this problem would be the same thing. So from 1960 to 2020, we've had on average a 3.15% inflation rate every year. Now you probably don't care, but to me that's a really big number. It's a disappointing number. Okay, now there's one more problem using this, and it is really quite difficult. So I'm going to show it to you, but I don't think I'm going to ask you to do one of these on any exercise. So suppose I ask, hey listen, let's assume a 4% inflation rate. How long before prices double? If the inflation rate is 4%, how long? Okay, so let's make it as simple as possible. Let's imagine something that costs $1. So then out in the future it's going to cost $2. And then I'm just going to plug it into this formula, and I get $2 equals $1 times 1 plus the growth rate, which we assume to be 4%, raised to the number years out. The reason that this problem is difficult is because of this term year. Since that thing is sitting up here in the exponent, we can't use simple algebra to solve it. Now I left a step out here, I'm sorry. In this first step here, I just divided both sides by 1 because, come on, that 1's not doing anything. So divide both sides by that 1, it just disappears. And I have $2 equals 1.04 raised to the number years out. Now, what to do? Some of you might remember from your old math days that when the thing you're trying to solve is sitting up in an exponent, you must use logs to solve it. So what I'm going to do is I'm going to take the log of both sides, right? That's easy. I just put log in front of that, log in front of that. And now in the next step, I'm going to apply one of the rules of logarithms that says if you have the log of something raised to a power, you can take that power out and set it in front. So that's what I've done here. I just took the power, this thing, and put it in front of the log. Okay? Now, I'm going to divide both sides by the log of 1.04, and I get this ratio. Now this thing looks hard, but actually you can do this in your calculator with 2 keystrokes. You can easily get the log of 2 and divide it by the log of 1.04, which I'm doing here, and now it's just simple algebra. And I get the number of years that it would take for prices to double, assuming a 4% inflation rate, would be exactly 17.673 years. So I don't think I'm going to ask you to do this one because it requires logs, and some of you probably haven't used logs in a long time. But all the other things I might ask you. In other words, if I gave you all this stuff, I could ask you to find the future value. If I gave you the future value and the present value and the number of years out it was, I could ask you to calculate the growth rate, right? If I gave you the growth rate in the number of years and the future value, I could ask you to find the present value. If I give you any, let's see how many there are. 1, 2, 3. If I give you 4, if I give you any 3 of these variables, you should be able to find the fourth one. Except maybe this, because to find that thing, since it's up there in that exponent, it requires logs. All right, let's put that away. Now, there are some conceptual problems with measuring the inflation rate. It's one thing to be an expert in manipulating the numbers. That's what we've been doing. But now I want to take a few minutes and get you to reflect on what those numbers really show. First, you need to think about how the index is calculated. It's calculated from a fixed basket of goods. In the case of the Consumer Price Index, it's roughly 400 items that they track every month. 400 items. So, the things we buy, it sounds like a lot, but there'd be many things that you might buy that aren't in those 400 items. Then, by assumption, each item that's in that basket of goods carries a weight. So, for example, if you have a tendency to buy a candy bar every day, the weight of that is its fraction of your budget, is much, much smaller than, say, your home mortgage, which maybe is a huge piece of your monthly budget. So there's fixed weights associated with every item that's in that basket of 400 items. And then, of course, the things that we buy change through time, so the basket is redesigned about every 10 years. Now, this is mechanical stuff, but over here I want you to think about some really tough questions. How are we to adjust for changes in quality? You buy a thing this month and you go back next month and the following month. Things, especially stuff that have electronic components to them, change in quality all the time. And then, how do we adjust for emerging new products and the loss of old products? I'm sure you're all old enough to remember some things that you commonly bought 5 or maybe 10 years ago, and now you don't buy them at all. New things that you buy nowadays which weren't available before. So how do we fairly merge those new products into the index and let the old products fall away? Then you might think consumers naturally avoid products whose prices are rising. So when something's getting more and more expensive, we find ways to economize on that. But that's not allowed by this assumption here of the fixed basket and the fixed weights. This kind of imaginary consumer, this composite consumer that the Bureau of Labor Statistics uses to calculate the inflation rate, buys exactly the same thing every month. So not only do consumers avoid products whose prices are rising, but they also naturally purchase more of products whose prices are falling. Something goes on sale, it's just natural that you would try to buy more of it to save money. So how should we allow this tendency of consumers in the index? At the moment, we don't allow it at all. At the moment, this robotic consumer buys exactly the same thing every month. Then finally, what about discounted prices? It sounds a little odd, but I'm sure you're very aware that in medical services, there is the list price of what something costs, and then there is the price that actually got paid by your insurance carrier. And the difference between the list price of a medical service and what the insurance company actually paid can be huge. It's also common in college tuition, not quite as dramatic as it is in healthcare, but there is the list price of college tuition, the charge per credit hour, and then there is the price that you actually pay after your tuition is discounted for any number of reasons. How should we take that information into consideration? Now we have some techniques for adjusting the CPI for these quality changes. The first one is really kind of simple. Have you ever gone to the grocery store and bought like a can of soup or a bag of potato chips or some other thing that's measured by weight and discovered that the weight is slightly bigger or slightly smaller than it was before? It's really common in soup cans and also in potato chips. Right? You might buy a 5 a 12-ounce bag of potato chips last time you went to the grocery store, and this time there's no such thing. Now it's the new economy size of 14 ounces, or it's the smaller size, or some such thing. So this kind of change in quality is easy to adjust. We just recalculate the price per some constant unit, like per ounce. You might think of M&M candies. The little bag of M&M candies gets bigger and smaller all the time. And I'm sure that's one of the items in the CPI. And I'm sure that they just calculate the price per candy instead of the price per bag. So that's an easy one. But sometimes the quality changes are really complicated. Like when an old refrigerator goes out of service and then they have the new improved model. So the new improved model might be more expensive, but also has features that the old model didn't have. Sometimes those features are really attractive, and sometimes the changes are not. So how shall we evaluate these quality changes? And of course, the answer depends on who you ask. It's really a difficult question. Here are some of the ways that the Bureau of Labor Statistics uses to try to evaluate these quality changes. Sometimes they use a panel of experts, and this panel of experts might be made up of engineers, marketing people, consumer advocates, and they have to decide somehow. Another technique is called linking, and in this class I won't show you how to do that. It's not difficult, and it's easy to do with a spreadsheet. Another technique that is really quite complicated is called the hedonic method, which uses regression equations to measure quality changes. And then my all-time favorite solution to quality changes is just to assume that nothing's happened. And while it sounds so absurd, that is the fallback position on many quality changes that are too difficult to measure in other ways. It's easy to kind of get a sense of what's happening to something that you buy in the grocery store, but many things that we buy are really services, and it's very difficult to figure out what's happened to the quality of a service. Think about medical services, legal services, insurance services. It's really difficult to get a quantitative metric on what's happening to those things. And oftentimes I'm embarrassed to tell you that they just assume there's no quality change. Alright, so let's summarize measuring inflation. Inflation is measured in several ways. The most common is the Consumer Price Index. The CPI data is easily available from the Bureau of Labor Statistics. Any business analysis that happens through time. So if you're in some sales meeting and they have sales tracked, for the last 10 years on some graph, or they have cost tracked, or they have profit tracked through time, if that analysis does not adjust for inflation, it is just wrong. So if you don't learn anything from my class except for this, if it's your job to present some data, and that data is denominated in dollars and it happens through time, you must adjust it for inflation. Otherwise, what you put up there is well, it's not true. Okay, while the CPI data looks precise, so if you go back and look at that slide that I copied from my Excel spreadsheet, it looks really, really precise. That precision is an illusion. Adjusting the data for changing consumer preferences, new products, and quality changes is conceptually impossible. So you have this 3 significant digits, and some of that stuff you had 4 significant digits. It's really not like that. Those digits are all following from some decisions that were made. The best we have is an estimate of inflation. This estimate is driven by many difficult and necessarily arbitrary decisions about how to treat changing product quality and offerings. Okay, that's it. You should practice the math problems that were in this thing, and if you want to look at the data in detail, just go to bls.gov and you will see it there. All right, thanks.